Hi guys, today we are going to open our series on systems of linear equations in two variables. What is a system of equations? A system of equations is just code for a group of equations. What is the solution to a system? Well, since we have equations in two variables, the solution will be the set of ordered pairs. What is the solution to a system? The solution to a system is a set of ordered pairs that are solutions to all the equations in the system. We are going to spread this unit about 5 videos, and this is the first of the 5 in the series. So in this video we are going to be solving systems of linear equations by graphing. Now the question is, how do we solve a system by graphing? To solve a system by graphing, you are going to graph both of the equations and see where the lines intersect, if they intersect at all. If the lines intersect at one point, then whatever that point of intersection is, that will be the solution. Okay. If the graphs are parallel, then the lines will never intersect, and if the lines will never intersect, then they don't have any points in common, so as a result the system has no solution. But what if when we graph the first line, as we're about to graph the second line, we realize that the graphs are the same? If the graphs are the same, then the system will have an infinite number of solutions, because they have all these ordered pair solutions that are common to both or all the equations in the system. So let's go ahead and do this. We're going to go ahead and do two fun problems. So the first the set of two, let's do this. So it says solve the system of equations by graphing. We always have to pay attention to the directions. When we only have one technique to go by, it's not a big issue. The issue comes when you have discussed all 3 techniques and then you just solve it however you want, but please follow the directions. Okay, so we are asked to solve this bad boy by graphing. So let's go ahead, graph each line and see where the lines intersect, if they intersect at all. You can graph these however you like. You can use the slope and y-intercept, or you can use the intercepts. I don't recommend you use the x and y intercept, because if you don't have integer intercepts, this is gonna get ugly really fast. So let's go ahead solve this by using the slope and y-intercept. Graph this. So let's go ahead, take our first equation, work your magic to write it in slope-intercept form. So we take our time to isolate the y term. After we subtract 2x from both sides, that will leave us with negative y equals negative 2x minus 4. To finish it off, to get rid of the times negative 1, we're going to go ahead, divide both sides by negative 1, and that will leave you with y equals 2x plus 4. Coefficient on x, so gentle reminder, an equation is said to be in slope-intercept form if it looks like this: y equals mx plus b, where m is the slope and b represents the y-intercept. The coefficient on the x term is 2, so that's our slope. Constant term is 4, so that is our y-intercept. So if the y-intercept is at 4, let's go ahead, locate 4 on the y-axis. Our slope is 2. For my peace of mind, I'm going to write it as a fraction. So our slope is 2, or 2 over 1. If the rise is 2, then we're going to go up 2. If the run is 1, we're going to go 1 to the right. So my game plan is to go up to 1 right. But as you can see, I need more graph space. We cannot guesstimate, okay? And we cannot change the scale because the scale on the y-axis is locked in. So we're going to rewrite the slope. So my game plan was to go up 2, but just kidding. Plans change. So we're going to have to go down 2. If we change the directions to the top, we have to change the directions to the bottom. So original game plan was 1 right, just kidding, 1 left. Okay, so we're gonna write this as negative 2 over negative 1. So you're always welcome to rewrite the slope. Rewrite, not change it. Quotient of negative 2 and negative 1 is 2. So we're still applying the same slope, just in a different format. So let's go ahead, go down to 1 to the right. And then for my peace of mind, I'm going to keep applying the slope. Why? Because sometimes my straight edge moves. And if my graph is a little bit off, then my answer is a little bit off. And that cannot happen. So let's apply it again. Down to 1 to the left. Down to 1 to the left. What? One more time? Cool. I love your enthusiasm. So let's go ahead, take our straight edge and connect the points. So that way, even if my straight edge moves a little bit, it's okay. I have a lot of points. So hopefully one of these will fit the mark. Okay, because we're gonna graph two equations, let me go ahead label this as line 1. Okay, so one equation down, one more to go. So for the second equation, let's go ahead work our magic to write this in slope intercept form. Okay, so you take your time, you isolate the y term, and when you do, that will leave you with y equals negative 3x minus 1. The slope is negative 3, the y-intercept is at negative 1, so let's do this. So if the y-intercept is at negative 1, let's locate negative 1 on the y-axis. If the slope is negative 3, with your permission, we're going to write it as negative 3 over 1. So the directions, down 3, 1 to the right. Down 3, 1, 2, 3, 1 to the right. Let's go ahead, take our straight edge, connect the points, or you know, you can always rewrite it. Okay, 3 over negative 1 is still negative 3. So with these new directions, up 3, 1 to the left. So up 3, 1, 2, 3, 1 to the left, which is that point that was already graphed. Okay, so let's go ahead, take our straight edge, connect these points. And whatever that point of intersection is, that will be the solution. So if my eyes don't fail me, I believe the lines intersect at negative 1, 2. So the solution is given by negative 1, 2. What is the solution to an equation? The solution to a system of equation is that one point or those ordered points, ordered pairs that are solutions to all the equations in the system. So in this case, it's negative 1, 2. Okay, for the grand finale, let's go ahead and knock out this system. So again, we're not given the liberty to solve it however we like. We have to solve it by graphing. So let's go ahead number these. I'm a big fan of numbering things. So work your magic. Isolate, put this in slope intercept form. So we'll subtract 3x from both sides, and that will leave us with negative y equals negative 3x minus 2. Work your magic to get rid of the times negative 1. Let's go ahead, divide both sides by negative 1. And that will leave us with y equals 3x plus 2. So this is in slope intercept form. So our slope is 3 and the y-intercept is 2. So let's do this. So our y-intercept is at 2. Let's locate 2 on the y-axis. The slope is 3. If you write it as a fraction, 3 over 1, 1, 2, 3. I'm out of space. Should I use it? I'm not going to. Okay, so we're gonna change the direction. So we're gonna go down 3 and then 1 to the left. So again, you can always rewrite it. Quotient of negative 3 and negative 1 is still positive 3. So let's go down 1, 1 to the left. So down 3, 1 to the left. So 1, 2, 3, 1 to the left. Now I'm gonna discard this, pretend I erased it. Let's go ahead, take our straight edge and connect the points. Yeah, this is not as easy as it looks. All right. Fantastic. So one graph down, one more to go. Let's go ahead, take our second graph, second equation. So that will give us 3x minus y equals 3. Put this in slope intercept form however you like. If I can read your mind, let's go ahead, isolate the y term and subtract 3x from both sides. Okay, this is not quite in slope intercept form. We want y equals, not negative y equals. So when we take our time, if I didn't make a mistake, that should leave us with y equals 3x minus 3. So the slope is 3. The y-intercept is at negative 3. Let's do this. So the y-intercept is at negative 3. Let's locate negative 3 on the y-axis. The slope is 3 again. So let's go ahead, write it as a fraction. We'll go up 3, 1 to the right. Up 3, 1 to the right. Okay, let's go ahead and do this. The question is, do you really have to label your graphs? No, the reason why I do it is so when I come back to my work, I can easily reference like, oh yeah, this one is the graph of the second equation and this one is the graph of the first equation. So with that being said, what is the solution? So when we solve a system by graphing, the point or points of intersection will be the solution because that will be the points that they have in common. But in this case, as you can see, the lines are parallel. And if the lines are parallel, then the lines will never intersect. And if the lines will never intersect, then there's no solution because they don't have anything in common. Cool. Okay guys, so that's the end of the first video. Thanks.